In this video, we're going to look at Azure Databricks Processing. Databricks is a data analytics platform that lets you build data pipelines and perform all types of analytics on the data. It's optimized for running in Microsoft Azure. And as we'll see, it supports both batch and stream processing. Databricks takes advantage of parallel processing, which improves performance by making better use of resources. It does this by processing different workloads using parallel threads that run at the same time, saving processing time. Parallel processing requires parallel workloads. Parallel workloads are workloads that are not interdependent. So for example, imagine processing two streams of data, one coming from thermostat A and another from thermostat B. If the processing for thermostat A and thermostat B are not dependent on one another, then they can be processed entirely separately and are parallel workloads. The two streams can be processed at the same time by two separate processes. If, however, the processing involves looking at both thermostat A and thermostat B data in certain time frames to determine aggregates, then the two workloads would be dependent and not parallel. This would not lend well to parallel processing. Azure Databricks offers a few methods for parallel processing. The first one is called parallel collection enumeration. When enumerating a sequence, such as an array of data values, a special keyword specifies that the enumeration can be run in parallel. This can be faster than enumerating in sequence, since multiple threads can be processed at once. In Databricks, using parallel collection enumeration allows only as many simultaneous threads to run as there are cores defined for the Databricks instance, and this is a limit. Furthermore, running in parallel is actually up to the Spark scheduler, which, for various reasons, may opt not to run certain threads in parallel. Therefore, you don't have direct control over the parallel processing with this call. Another option is invoking the fair scheduler pool. This generally works faster than the parallel collection enumeration call, because the thread count, or number of elements run in parallel, is not limited by the number of Databricks cores. Furthermore, Spark always runs these pools in parallel. So this makes the fair scheduler pool method a more predictable form of parallel processing. Databricks can process images as workloads as well. It can read an image file in as a data frame. When it does, the image data frame is broken down into the following properties: the origin or URI for the image, the width and height of the image in pixels, the N channels or number of color channels, the mode, which informs the format of the image data, and finally the data itself in binary format. Image processing can be useful for displaying images in Databricks or for doing analysis of the image data itself, such as looking for image patterns. Next, we'll look at how Databricks manages batch processing. Batch processing is used to prepare big data for analysis. Large chunks of data, called batches, are read in and processed. Batch data is generally high latency, since the processing has to work through large chunks of data. So batch processing is best used to prepare data for offline analytics, or other scenarios that don't require real-time or near real-time processing. Azure Databricks supports several languages for batch processing, including Python, Scala, and Spark SQL, making it flexible to work with. Under the hood, Databricks runs batch processes on Spark clusters. A Spark cluster is a processing unit that runs batch processes on one or more processing nodes in a cluster, taking advantage of parallel processing if possible. Because batch processing is a long-running process, it doesn't run continually. The Spark cluster often gets activated only when there's a new batch to process, and then has a timeout where it shuts down until the next batch process starts. Spark clusters can autoscale as larger and smaller batch processes are encountered. Databricks batch processing can integrate with Azure Active Directory for identity and access management. And Databricks batch processing can integrate with many Azure services as both inputs and outputs, such as Azure Blob Storage and Azure Synapse Analytics. The next type of processing Databricks can do is stream processing, which processes incoming messages with minimal latency. Unlike batch processing, this is near real-time processing, where the processing takes place on a small amount of data, typically as it streams into the system. It's often used to detect real-time patterns in the streaming data, or to transform the data real-time before it's stored in the system. Databricks stream processing includes the ability to program both imperatively, meaning you write code to tell the process what to do, or declaratively, meaning that you describe what you want done, but not how to do it step by step. Most programmers are more familiar with imperative programming, which is what you're doing when you write algorithms in a language like C# with explicit control flow. On the other hand, SQL statements are an example of declarative programming. You're not telling SQL Server step by step what to do, but rather you're describing, via the SQL statement, what you wish to achieve. Databricks stream processing supports many different languages, such as C#, Python, and Scala for imperative programming, and Spark SQL for declarative programming. Several Azure Stream inputs are supported by Databricks, including Event Hub for receiving messages, Data Lake for reading blob files, and IoT Hub for receiving streaming data directly from physical devices. Some features of Databricks stream processing are handling of any input format with custom code. In other words, you must parse the incoming data and understand the format, but Databricks gives you the programming environment to be able to do that. Databricks can handle out-of-order and late events. Every piece of data in a data stream has a timestamp associated with it that tells when that data arrived in the system. Sometimes it's important that the data be processed in order, or that the processing waits until all the data is in. For example, imagine your stream processing calculates a rolling hourly average of temperature from an IoT thermostat on the fly. It would have to wait and collect an hour's worth of data before calculating the average. It would also need to verify that data didn't come in late. Say a reading just before the end of an hour was delayed and didn't come into the system until just after the hour. Then it would be in the wrong sample if out of order wasn't taken into account. And beyond this, Databricks has temporal functionality that allows for aggregates like the one I just described, where time windows are important for processing the data. In this video, I'm going to show you how to instantiate an Azure Databricks Workspace, start an Apache Spark cluster on that workspace, and create a notebook to run code on that cluster. So I'm in Azure, and on my home page, at the top left, I'm going to click Create a Resource. And on the new window, in the search box, I'm going to type Azure Databricks and select Azure Databricks. Now on the Azure Databricks window, click Create at the top. So now we're on the Create an Azure Databricks Workspace page, and I'm on the Basics tab, which is the farthest tab to the left at the top. And under Project Details, it's already filled in my subscription because there's only one, but you can choose your subscription. I'm going to choose my resource group, or you can choose to create a new one. And under Instance Details, I need to give it a workspace name. So I'm going to keep this simple and just call it Databricks. And just to keep it unique, I'm just going to give it some numbers afterwards. And I'm going to leave it in the region Canada Central, which is where I am. And I'm going to leave the standard pricing tier on. Now I'm going to click Review and Create. And validation succeeded, so I'm going to click Create at the bottom left. Okay, my deployment is complete. So in the center of the screen, I'm going to click Go to Resource. And it takes me to my Databricks instance. Okay, so now I'm in my Azure Databricks Service instance. And I'm on the Overview on the left menu, the very top option. And on the right, I see my overview. And if I scroll down a bit, I see a big blue button with a red icon above it, and it says Launch Workspace. So I'm going to click on that. Okay, so now I'm in Azure Databricks. Now the first thing I need to do before I do anything is start an Apache Spark cluster. because that's what all my code is going to run on. So I'm going to go to the left menu, and sixth button from the top is clusters, and I'm going to click on that. And on the right-hand side, I see my cluster screen, and at the top left of that, there's a blue button that says Create Cluster, so I'm going to click on that. So now I have a new cluster screen, and there's many options here. Now I'll show you what I'm going to run. I'm going to run a very simple option. First, I need a cluster name, so I'm just going to call it demo-cluster. Cluster mode can be standard, in which case you choose the runtime version and several other options. I'm going to simplify this by pulling down cluster mode and choosing single node. And the reason I can do this is because we don't have a lot of requirements here, so we don't need a lot of nodes to run this. We just need a single node. For pool, underneath cluster mode, I'm going to leave it at none because that's what I have for single node. Because it's a single node, so there's no pool. Databricks runtime version, I'm going to leave it at the default, but I'll pull it down here and you can see that you can run a lot of previous versions of Spark and Scala. And autopilot options is important. Terminate after 120 minutes of inactivity. This is important because clusters are expensive, they cost, and so you don't want them running all the time. So this will turn it off after 2 hours. And node type, there are several different node types for optimizing memory, optimizing storage, and compute. We're just going to choose a general purpose because we're not doing anything complicated. So at the top, there's a blue button that says Create Cluster, so I'll click Create Cluster. Now it's important to note that clusters take a few minutes to start up. That's not unusual. So I'm going to leave this running and I'm going to pause and come back when it's done. Okay, so the cluster is started up. And the way you can tell when a cluster is started is in the top left of the cluster screen, there's a green circle which means running. Otherwise, there's a green animation there that tells you that it's still starting up. So on the left options, if I go back down to clusters and I click on that, and I can see my demo cluster in this table, and it has a green circle on the left, so it's running. So now I can create a notebook to run code against this cluster. So on the left, I'm going to click Home, which is the second button from the top. So I see my workspace on the right, and under Users, I see my user. And if I click the little caret beside my name, I can choose from the menu Create, and I can create a notebook. So I'll click Create Notebook, and I get a Create Notebook pop-up. I can give it a name, so I'm just going to call this Demo-Notebook. I can give it a default language, so you can see it can be Python. When I look at this pull-down menu, Python, Scala, SQL, or R. I'm just going to leave it at Python for now. And the cluster automatically chooses demo cluster because that's the only cluster running. But if you had other clusters, you could pull down this menu and choose the cluster you want to run it on. So on the bottom right of Create Notebook, I'm going to click Create. And now on the screen, at the top left, it says Demo Notebook, and in brackets, it says Python. So I know I'm running Python script. Now I have a command window, which is gray, and I can enter code in there, and then I can hit Shift-Enter to run it. So in conclusion, I've shown you how to create an Azure Databricks Workspace, start an Apache Spark cluster, and then create a notebook that's tied to that cluster. When you create a job in Databricks, by default it runs under the identity of whoever created it. There can be issues with this long term. For example, what if the person who created the job leaves the company and their identity in Azure is removed? This is going to affect the Databricks job. Therefore, it's common to make a service account the owner of the job. A service account is a created identity that's not associated with any user. Its sole purpose is to be the owner of the job. In this video, I'm going to show you how to set up a service account and make it the owner of a job in Databricks. So I'm in Azure, and my first step is going to be to create the service account. I do that in Azure Active Directory. So in the top left of my screen, I'm going to click Azure Active Directory. And on the menu on the left of Azure Active Directory, I'm going to go under the Manage section. And under the Manage section, I'm going to click App Registrations. Now on the right, at the top, I'm going to click New Registration, which is on the left-hand side. Now on the Register an Application window, I'm going to give it a name of demo-reg and click Register at the bottom left. So now I've created my registration. Now if you're following along with me, as I go I'm going to tell you what information you should copy to use later. So in this demo registration, I'm going to need two pieces of information from the overview. I need the application ID, which I'll copy, and I need my directory or tenant ID, which I'll copy. Now a third thing we need to do with the registration is in the options on the left, under Manage, there's a Certificates and Secrets. I'm going to click on that. And we need to create a client secret. So if I scroll down on Certificates and Secrets, I get to Client Secrets, and there's a button that says New Client Secret. I'm going to click that. And then on the Add a Client Secret window that pops up, I'm going to click Add at the bottom left. This creates a new client secret on the registration. And in the Client Secrets list, the third column from the left is Value, and I'm going to copy that value to clipboard. And I'm going to store that as secret. We'll need that later. So this app registration is our service account. Now at the top left, I'm going to click Home. And the next step is to create our Databricks instance. So on the top left of my home page, I'm going to click Create a Resource. And on the New page, in the search box, I'm going to type Azure Databricks and choose Azure Databricks. Now in the Azure Databricks window, I'm going to click Create. So I'm on the Create an Azure Databricks Workspace window. I'm on the Basics tab, which is on the far left. And under Project Details, there's a subscription to choose. Now it's already chosen mine because it's the first one. And then Resource Group, you can either create a new resource group to put it in, or you can choose an existing one. I'll choose an existing one. Then under Instance Details, it needs a workspace name. So I'm just going to call this Databricks 2466 just to keep it unique. And region, Canada Central is fine. Now this is important. Pricing tier, you need to choose trial premium 14 days because you cannot do this demo unless you're on the trial or the premium. So we'll choose trial. And then at the bottom left, I'll click Review and Create. So validation succeeded. So at the bottom left, I'll click Create. Okay, so that's deployed. So I'm going to go to the top left and click Home. And then on my home page under Recent Resources, I see my new Databricks instance, Databricks 2466. So I'm going to click on it. And now it takes me to the Databricks overview. And if I scroll down on the overview, I can click Launch Workspace. So here we are in the Azure Databricks Workspace. And the next piece of information that we need is what's called a personal access token. It allows us to talk to Azure Databricks. So in the top right of my screen, I'm going to click My User. And under that, there's an option called User Settings. I'll click on that. And on User Settings, to the left, there's a Generate New Token button. I'll click on that. Now I get a Generate New Token pop-up. And there's a comment, what's this token for? I'm just going to type in demo. And on the bottom right, I'll click Generate. Now I get a Generate New Token pop-up, and it's created a new token it's showing on the screen. Now I'm going to copy that token, and if you're following along, do the same thing. And I'm going to save it as a Databricks Personal Access Token, because we'll need that later. Now I'm going to click Done on the Generate New Token pop-up. So the next thing we need to do, we've now created the service account in the form of an app registration in Azure Active Directory, and we have this personal access token for Databricks. Now what we need to do is we need to register that service account or application registration with Databricks. The way we're going to do that is with an API call. Now you can make an API call several different ways, but the way I'm going to do it in this demonstration is by using a useful program called Postman, which I have up right here. And I have some curl statements saved in files, and I'm going to use them here in Postman. So at the top left of Postman, I'm going to click Import, and I get an import pop-up, and it's on the far left tab, which is File. And in the middle of the File tab is an Upload Files button. I'm going to click that. And I'm going to go to my files, and I have a file called add service account to Databricks. So I'm going to double click on that, and that imports my API call. So at the bottom right of the import pop-up, I'll click import. And now on the right-hand side of Postman, I now have a tab, which is a post tab, and it's my request. In the URL portion of my request, I have to fill in the per workspace URL. To get that, let's go back to Azure for a moment. And on the overview of Databricks, there is a URL, and that's what we need. So I'm going to copy that. Now I'm going to go back to Postman. And in the URL section of my request on the right, I have to place that URL here. I have to replace the HTTPS portion as well. The next thing I need to do, in the tabs below the URL, third from the left is headers. I'll click on that. And under headers, there's a header called authorization. And it has, in triangle brackets, it says bearer space, and then in triangle brackets, personal access token. That's where we put that personal access token that we got from Databricks. So that's why we stored that. So I'm going to copy that and paste it here. Remember to leave the space between the word bearer and the token. Now I'm going to go to the tab beside headers on the right, which is body, and there's a few things to fill out in the body. First, on line 5 is application ID. That's the application ID of our app registration in Azure Active Directory that we stored earlier. So I'm going to retrieve that and paste it here. The next one is display name. I'm going to call this demo-service account. And what this does is it also allows cluster create you see on line 9. So it allows this identity to create clusters in Databricks. So at the top right of the request, I'm going to click send. Okay, so at the bottom, it says 201 created in the results. So that was successful. So the next step we're going to do is create a key vault to store the secret. Remember when we created the app registration in Azure Active Directory, we created a client secret. We need to store that safely, and the way to do that is a key vault. So we're going to jump back to Azure for a moment, and I'm going to click Home at the top left of Azure, and then at the top left of my home page, I'm going to click Create a Resource, and on the new window, I'm going to type Key Vault, and I'm going to choose Key Vault. On the Key Vault window, I'll click Create, and then I'm on the Basics tab of Create Key Vault. So it chooses my subscription. I need a resource group. I'll choose the existing one. Under Instance Details, I need a Key Vault name. So I'll just call this Key Vault 2466. I will put it in the same region as everything else I have, which is Canada Central. And pricing tier standard is fine. At the bottom left, I'll click Review and Create. And then at the bottom left, I'll click Create. Okay, so that's complete. So I'm going to click Go to Resource under Your Deployment is Complete, and it takes me to my Key Vault. Now the next thing we're going to do is store the client secret for our Azure Active Directory app registration in this Key Vault. So on the left menu, under Settings, I'll click on Secrets, and on the Secrets window on the right, at the top left, there's a Generate/Import button. I'll click that. Now I'm on a Create a Secret window. Upload options, I'm going to leave it as manual. Name is the name of our secret. So I'm going to call this demo-secret. And if you're following along, save this name because we're going to need it later. The value is going to be the client secret that we generated and stored back when we created the app registration. So that's value. And then I'm going to click Create at the bottom left. So that creates a secret in my Key Vault that is storing my client secret for my service account, or otherwise called an app registration. So now the next step we're going to do is we're going to tie this Key Vault to Databricks. And the way we're going to do that is with something called a secret scope, which Databricks has. So I'll go back to Home at the top left, and under Recent Resources on my home page, I'll click my Databricks again. And under Databricks on the right of the overview, I'm going to copy the URL, and I'm going to open a new browser tab, because we're going to go to a UI that you need to type the URL into. So I'm going to use the root URL of the Databricks. Then at the end of the URL, I add /secrets/create S scope and hit enter. And this takes me to a create secret scope window in Databricks. This is in my instance of Databricks. So I'm going to create this secret scope which ties that key vault to Databricks. The first thing it needs is a scope name. So I'm going to call this demo-scope. And I'm going to save that. And if you're following along, save that name because you're going to need it later. Manage principal creator is fine. Now you need two pieces of information for your Azure Key Vault. You need a DNS name. So if I go back to Azure for a moment, and I click Home at the top left, and then under Recent Resources, I click my Key Vault. Now if I go down to Settings on the menu on the left, and I go to Properties, I want to copy two pieces of information. The first one I'll start off with is Vault URI, which is fourth from the top. I'll copy that, and if I go back to my Create Secret Scope in Databricks, that's a DNS name. So I'll paste that. Now if I go back to Azure, the next thing I want to copy is the next value down, which is Resource ID. So I'll copy that, then I go back to my Create Secret Scope Databricks window, and that is the Resource ID, and I paste that in. Now at the top right, I'll click Create. So I get a pop-up window that says the secret scope named Demo Scope has been added. So that's great. I'll click OK on that. So the next step is to grant my service account or app registration access to the secret scope that we just created. So that's another API call. So I'm going to go back to Postman. I'm going to close the request that we've already used. And at the top left, I'm going to click Import. And under File, I'm going to click Upload Files. And I have another file here called read access to secret scope.curl. I'm going to click that and click Open at the bottom right. Now at the bottom right of the import window, I'll click Import. So now let's fill in the request again. So in the URL of the request on the right hand side, again, I need to fill in the URL of the workspace. So I will just quickly grab that, going back to Azure. And if I click Home at the top left, and in Recent Resources, I go to my Databricks. And on the overview, I copy the URL. Now back to Postman. I will replace the beginning of this URL with that URL. Now under Headers, below the URL, third from the left, I click on that, and under Authorization, again, I need to fill in the personal access token that we created earlier for Databricks. And then beside Headers, I'll click the tab Body, and we need to fill in the scope name and the application ID, which are on lines 2 and 3 in the code window in the middle of the screen. So the scope name is, I asked you to save that, but it is demo-scope. That's the secret scope that we created. The principal is our app registration in Azure Active Directory, the application ID. So I will get that and paste it in. And at the top right, I'll click Send on the request. So at the bottom, the result is 200 OK. So that's fine. So now let's go back to Databricks. And I'm going back to the Databricks Workspace. And what I'm going to do now is create a new notebook. So I'm going to click Workspace, and I'm going to click Users under Workspace. And an interesting thing is you will see that there's me, which is bill.brooks, and there's another user, which is a big GUID, basically. And this big number is actually the application ID of the app registration that we created in Azure Active Directory. So that is now a new user that we've created under Databricks. So I'm going to create a notebook under that new user. So I'm going to click on the caret beside it, choose Create, and click Notebook. Now I get the Create Notebook pop-up. It needs a name, so I'm just going to call it Demo-Notebook. Default language Python, that's fine. We're not going to select a cluster because the cluster will be auto-generated when the job runs that we create. So I'll click Create at the bottom right. So that creates a new notebook. Now I'm just going to leave that for now. Now the next step is to create a job. So on the menu on the left, I'm going to go down to Jobs. Click on that, and at the top left of the Jobs window on the right, there's a Create Job button. So I'll click Create Job. Now under Task on the job screen, it says Select Notebook. I'll click on that, and I get a Select Notebook pop-up. I'll click Users, and I'll choose my user, which is actually my app registration. And then I will choose my demo notebook. And I'll click Confirm at the bottom right. Now, at the top of the screen, I will click Create. Oh, I need to give it a job name, so we'll call it Demo-Job. And I'll click Create. And I've successfully created the job. Now, there's some configuration we need to do on the cluster that's associated with this demo job. So now on our demo job screen, under Task, under Cluster, there's an Edit button to the right of the cluster details. Click that, and I get a pop-up window that says Configure New Cluster. If I scroll to the bottom, there's an Advanced Options section. If I open that, there are tabs for Spark tags, logging, and scripts. On the Spark tab on the left, under that, there's a Spark config section. I'm going to fill in that Spark config section, and we're going to have to fill in some blanks here. Now, if you're following along with this, you should have access to a file called sparkconfig.txt, and it will have this contents in it. So there's a lot of information that has to do with the cluster configuring itself, and we need to give it some of the secret information that we've been collecting as we did this. So on the line that says fs.azure.account.auth2.client.id, etc., we need to fill in the secret scope name. And if you recall, that was demo-scope. We need our application ID. That's our app registration application ID. So we'll fill that in. And then on the next line, we have in triangle brackets secret scope name. So that was demo-scope. And we need the secret name. That's the name of the secret in the key vault. And we called that demo-secret. And the last piece of information we need to fill in here on the very last line is in triangle brackets directory-ID. So this is the tenant ID, another piece of information we stored about our Azure Active Directory app registration. And then at the bottom right, I'll click Confirm. So with that, we've completely configured the job to run under the application registration we created. The very last step we have is to set that service account to actually be the owner of this job. So on the left menu, I'm going to click Jobs. And on the Jobs screen, we can see in the table our demo-job. And if I click on demo-job, and then I have two tabs at the top of the demo job screen. One is runs that it's currently on, and the other is configuration. So I'll click on configuration. And then if I scroll to the bottom of configuration, there's a section called permissions. Who has access? So I can add my user. Under that, there's a section called add users and groups. And there's a pull down menu. I'll pull that down and I can choose my demo service account. And I can say is owner as the option beside it to the right. And beside that to the right, I can click add. And it's warning me in red above, the job must have exactly one owner. And currently Bill Brooks, myself, is the owner. So I will hit the X beside myself and remove myself from the list. Then if I scroll to the top of the demo job screen, I can click Save. So that is all there is to it. Now, every time this job is run, it will not run under me, who created the job, but instead it will run under the service account associated with the app registration. In this video, I'm going to demonstrate how to read data from a SQL database using an Azure Databricks notebook. So I'm in Azure here on my home page. There are two resources that you're going to need for this. The first one is Databricks. So I have an Azure Databricks instance called Databricks 2466, and the other one is a SQL database. So I'm going to step you through creating the SQL database resource. So on the top left, I'm going to click Create a Resource. And on the New page, I'm going to type SQL Database and choose SQL Database. On the SQL Database window, I'll click Create. And on the Create SQL Database screen, I'm on the Basics tab, which is the far left. You need to choose a subscription. It already chooses my default one. And you need to choose a resource group or create a new one. So I'm choosing the one I already have. Under Database Details, I have to choose a database name. So I'm just going to call this SQL DB-20466. And then I need a SQL server to run this database on. Now, if you have one existing, you can choose it. I don't have a SQL server set up, so I'm going to hit Create New. And I get a blade on the right called New Server. So it needs a server name, so I'm just going to call it SQL Server 2466. Server admin login, so this is my sysadmin user. I'm going to call my user bbrooks26 and give it a password. Confirm that password. And then the last thing is location. And I always choose Canada Central since that's what everything else is in that I have in my resource group. At the bottom left of the blade, I'll click OK. And then at the bottom left of the Create SQL Database screen, I'll click Review and Create. And then I'll click Create. So that's going to take a few minutes to deploy, so I'm just going to pause and come back. Okay, so that deployment is complete. So now I'm going to click Home at the top left of my screen. And in my recent resources, I'm going to click my resource group. And in my resource group, if I scroll down at the bottom, I have SQL DB-2466 and SQL Server 2466. So we're going to be dealing primarily with the database. The server is what the database runs on. So I'm going to click the SQL Database instance. And that takes me to the overview. Now the first thing we're going to do is set the firewall so that we can talk to the SQL database effectively. So at the top of the overview, fourth button from the left of the main menu, there's a Set Server Firewall button. I'm going to click that. And this sets firewall settings not just for this database, but for the whole server. So at the very top, there's an Add Client IP button, third from the left. I'm going to click on that. And what that does is if I go down the screen to where there are IP rules, and it says rule name, start IP, and end IP, there's a table. It's added the client IP or the IP of this instance to that rule list. So that way we can actually log in and use the database from Azure. So at the top left, I'm going to click Save. And I get a success pop-up. So I'll click OK. And then at the top of my screen, I'm going to click my SQL DB-2466 to back up back to the overview. Now what we're going to do is log in and create a table that we can read from Databricks. So on the menu on the left, I'm going to go to Query Editor. Click on that. And on the right-hand side, I get a login screen. So I'm going to log in as my sysadmin, bbrooks26, and I enter my password. And I hit OK below the password box. And now we're in the query editor. So on the right-hand side, I have a query edit box. I'm going to run a create table script. So on line 1, it says create table people. From line 2 to 5, I have my fields defined. So line 3 is first name, which is a varchar 50. And on line 4 is last name varchar 50. So a very simple table with a first name and a last name for people. So at the top left of the query editor, I'm going to click Run. And if I look at the results at the bottom, that was successful. So now I'm going to insert some records into that table. So I'm going to replace the create table code with an insert into. So on line 1, insert into people in the query editor. On line 2, it's going to be entering first name and last name as the fields. And the values starting on line 4 to line 7 are Bob Smith, Donna Lewis, Stephen Price, and Karen Black. So at the top left above my query editor window, I'm going to click Run. And that says query succeeded, and it put in 4 rows. So now we have a table called People that has some contents. So our goal here is to read that from a Databricks Workspace. So I'm going to click Home at the top left of my screen. It asked me if I wanted to save my changes. I just hit that it could throw the changes away because I have them saved elsewhere. Now I'm going to open my Databricks Workspace. So I'm on my home page of Azure. Under Recent Resources, I'm going to click Databricks 2466. It takes me to the Overview page, and I'll scroll down in the Overview page until I get to the Launch Workspace blue button. So I'll click that. So now I'm logged into Azure Databricks. Now the first thing I want to do is start a new cluster because I need a cluster in order to run my notebook. So on the left menu, 6 button down from the top is Clusters. I'll click on that. And on the right, I get a big Clusters menu, and it has nothing in the Clusters table. But at the top left, it has a Create Cluster button. I'll click that. And now I get a new cluster window. So it's asking me for a cluster name. So I'm just going to call it demo-cluster. Cluster mode, I'm going to change that to single node because this is a very simple run. So we only need a single node. We'll keep it simple. And Databricks runtime version, I'll just leave it at default. And everything else I'll leave at default. So at the top of the new cluster page, I'll click Create Cluster. So at the top left of my demo cluster page, there's currently a spinning green animation, which tells me that it's starting up the cluster. This can take several minutes, so I'm going to pause and come back when it's done. Okay, so our cluster has started. And we know that because there's a solid green circle to the left of the name of my cluster at the top of the screen. So now what I can do is I can create a notebook and run it under this cluster. So I'm going to click the Databricks button at the very top of the left menu, and that takes me to the main Azure Databricks page. And under Common Tasks at the bottom left of the screen, I'm going to click New Notebook. So this brings up a Create Notebook pop-up, and I can give it a name. So I'm just going to keep it simple, call it Demo Notebook. And default language is Python, that's fine. And you notice it automatically chooses the cluster I created because it's the only one I have. So at the bottom right of the Create Notebook pop-up, I'll click Create. And now I have my notebook. I see at the top left it says Detach, so I'll pull that down and choose Demo Cluster. And it says, are you sure you want to clear the notebook state? Yes, I'll hit Confirm at the bottom right. There, now we're connected to Demo Cluster. So now I can add code to the code window in the center of the screen and connect to Sql Database. So here's the code, and it's very simple. We're creating a URL, which is going to be a connection string that's going to connect us to the database. So we need a few pieces of information here. On line 1 is host. So if I go back to Azure for a moment, and I'm going to click Home at the top left of Azure, and under Recent Resources, I'm going to go to my resource group. And under my resource group, I will find the SQL Server, SQL Server 2466, and I'm going to click that. Now on the left, under Settings, there's Properties. So I'll choose Properties. And the server name is on the Properties page. It's SQL Server 2466.database.windows.net. So I'll copy that. And then I'm going to go back to Databricks and paste that for host on line 1 in the code window. On line 2 of the code window, it's asking for the database. So if I go back to Azure and I click Home at the top left of Azure, and if I look under Recent Resources, I don't even actually have to go to it. My SQL database is called Sql DB-20466. I can see that. So if I go back to Databricks on line 2, that's what I'll enter, Sql DB-2466. Now lines 3 and 4 are for credentials. This is going to be my sysadmin login. So user on line 3 is bbrooks26 for me. And line 4 is my password. And line 5 will create a URL which will use all of those pieces of information. On line 7, we're going to use the Spark object, and we're going to read using that URL and specifying the table of people. And then on line 8, we're going to display that data frame. So I'm going to hit Shift Enter, and let's see how this goes. Now we're getting an error here, a SQL Server exception, that's basically saying that the firewall of the database is blocking the IP address, which is 20.48.147.194. So that would be the IP address that Databricks is trying to talk on. So we're going to put in a firewall rule. There's several ways you can open this up. There are options in the firewall to open up to all Azure resources, or you can open up to specific IPs. So for this case, why don't we go and add this IP address to the rules of our firewall? So I've copied that IP address. I'm going to go back to Azure, and I'm going to go to my Sql database, Sql DB-20466 under Recent Resources. And at the top of the screen, fourth button from the left, I'm going to click Set Server Firewall. Now, if I go down in the firewall settings, down to the rules, which is the table that starts with rule name, start IP, end IP, I'm going to enter a rule name. Under rule name, I'm going to give it a name of Databricks. And the start IP is going to be the IP address that it's having an issue with, and the end IP is the same IP address. And at the top left of the screen, I'll click Save. So I get a success pop-up, so I'm going to click OK. And now I'll go back to Databricks, and let's try to run this again. I'll put focus on the code window, and then I'll click Shift Enter. So that's done the job. Now it's run, and you can see that we have the data, first name and last name, Bob Smith, Donna Lewis, Stephen Price, and Karen Black. A batch load flow contains 3 main steps. In the preparation step, the environment is spooled up. This might be a Spark cluster spool up in the case of Databricks, for example. Optionally, other processing can take place as part of the prep, such as the batch data being collected and validated. Then the actual processing takes place. This varies greatly depending on application. Perhaps it's generating aggregates for offline analysis that's subsequently stored to a sync database. All of this work would be part of the processing. The completion step then cleans up anything that needs to be taken care of after the processing, and the environment is typically torn down. When troubleshooting a batch load flow, it's important to understand these 3 steps and how each one might fail in different ways. On preparation failure, the batch flow run will be aborted. For this reason, the preparation step should include any tasks that must succeed for processing to take place. The examples I gave were spooling up the environment, reading input data, and validating the data for processing. If the environment spool up fails, there's no point continuing, so the process is aborted. You might want to consider, however, whether to perform data load and validation in the preparation step, because if any of the validation fails this step, then the entire process is aborted, and that may not be what you want. Depending on whether a data validation may indicate part of the batch can still be processed. When the preparation fails, you should be aware that it may waste resources. For instance, if a Spark cluster environment is spooled up and then the preparation fails, it may continue running for some time, wasting resources and costing money. For this reason, preparation fails should be an exception that doesn't happen very often. If these are happening all the time, you should reconsider how you've set up your batch flow load. Next, we have failure during processing. This can be due to logic failure. For example, your code results in an array overrun in certain conditions. It can be caused by I/O failures if you're uploading data during your processing, or I/O failures during downloading as you write data to a sink. And batch processes typically have a maximum time elapsed setting, which is the maximum time a batch process will be allowed to run before it times out. You should consider all of these possible failure points when troubleshooting your batch process. And finally, your batch process could fail in the completion step. You should carefully consider how you clean up in the completion step, because if you don't clean up properly, resources could be left in a bad state, such as a database connection being left open. In some flows, it may be impossible to guarantee all resources are left in a good state, even if completion fails. But your logic should try. For example, if your completion logic closes a database connection, and that close fails, does your logic then leave the Spark cluster running, or does it log the database connection failure and then attempt to shut down the cluster? Completion failures are notoriously difficult to detect, because it may look like your batch load flow is working just fine if you look, for instance, at what's showing up in your sync database. You might only know something's wrong if you look at the logs, so log monitoring is important. Speaking of logs, when troubleshooting, log files are going to tell you the most about what's happening with your batch loads. So make sure you're logging appropriately in your code. Most batch load systems will have several log files for the different steps in the flow. Make sure you know where to look for them. The logs should be monitored regularly, ideally by an automated notification system that tells you when something is wrong with the load. Microsoft Azure allows you to consolidate these logs in an Azure Blob storage account in its batch load flow service, which is a convenient way to keep all the logs in one place. In this video, I'm going to demonstrate how to configure a Cosmos DB endpoint in Databricks. So the first thing we need is a virtual network that contains both our Databricks and our Cosmos DB. So in Azure, on the top left of my home page, I'm going to click Create a Resource. And on the New page, I'm going to type Virtual Network in the search box. And I'm going to choose Virtual Network. And on the Virtual Network page, I'll click Create. So it takes me to a Create Virtual Network page, and I'm on the Basics tab on the left. So under Project Details, I choose a subscription. It's already got my subscription in there. And I can either create a new resource group or choose one I already have. So I'll choose the one I have. And under Instance Details, I need to give it a name. So I'm going to call this Virtual Network 2255. And I'm going to choose my standard region that I always use, which is Canada Central for these. And then at the bottom left, I'm going to click Review and Create. Now it says Validation Passed at the top of the screen, so now I'm going to click Create at the bottom. Okay, my deployment is complete. So in the middle of the screen, I'm going to click Go to Resource, and it will take me to the overview of my virtual network. Now I need to add an address space for Databricks. So in the options on the left, under Settings, the first option is Address Space. I'm going to click on that. And then I'm going to add an additional address range. There's a default 10.1.0.0.16, so right under that, on the right-hand side, I'm going to enter 10.180.0.0/16. That will be my range for Databricks. And at the bottom, I will click Save. Now we're going to create a Databricks instance and connect it to this virtual network. So I'm going to click Home at the top left. And on the home page, I'll click Create a Resource at the top left. And on the New screen, in the search box, I'll type Azure Databricks and choose Azure Databricks. Now in the Azure Databricks screen, I'll click Create. Now I'm on the Create an Azure Databricks Workspace screen. I'm on the Basics tab. And under Project Details, I choose a subscription. It's already chosen it for me. I choose a resource group. Under Instance Details, I'll give it a name, and I'll just call it Databricks 2255. And I'll leave the rest defaulted. And at the bottom of the screen, I'll click Next Networking. Now I'm on the Networking tab. And the second option in Networking tab is Deploy Azure Databricks Workspace in your own virtual network. I'll click Yes for that. Now it asks me for the virtual network. So I'll choose My Virtual Network. And now I need to fill in details about the public subnet and private subnet. And we're going to split the IP addresses on the address range we chose on the virtual network between these. So the first thing is a public subnet name. I'm just going to keep it simple. It's called public subnet. Public subnet CIDR range is going to be 10.180.0.0/18. The private subnet name, I will just leave as private-subnet. Private subnet CIDR range is 10.180.64.0/18. Now at the bottom left, I'm going to click Review and Create. So validation is succeeded. So at the bottom of the screen, I will click Create. Now it's going to take a little while to deploy Databricks, so I'm just going to pause and come back when it's done. Okay, deployment is complete. So now we're going to add a Cosmos DB endpoint on our virtual network. So I'm going to click Home at the top left. And in my recent resources on the home page, I'm going to open up my virtual network 2255. And on the left options, under Settings, I'm going to click the third one down, which is Subnets. Now you'll see that I now have a default subnet and also public subnet and private subnet. And you can see those are delegated to Databricks. So I'm going to click in the table on the right on public subnet. And I get a blade on the right that's called public subnet. And if I scroll down, there is a section called Service Endpoints. And there's a pull-down menu called Services. So I'll pull that down. And the one I want to choose is Microsoft.Azure Cosmos DB from that pull-down. And then at the bottom left, I'll click Save. So that creates my endpoint for Cosmos DB in the virtual network. Now I need to create the actual Cosmos DB account. So I'll click Home at the top left. And at the top left of my home page, I'll click Create a Resource. And on the new page, I'll type Cosmos DB. And I'll choose Azure Cosmos DB. And then on the Azure Cosmos DB page, I'll click Create. And now I'm on the Create Azure Cosmos DB account page on the Basics tab. So under Project Details, I choose a subscription. I choose a resource group. Under Instance Details, I have to give it an account name. So I'm just going to call it Cosmos DB 2255. And I'm going to place it in Canada Central under Location. And the rest I'll leave default. And at the bottom, I'll click Next Networking. Now I'm on the Networking tab. And under Network Connectivity, I can choose a connectivity method. So I'm going to choose Public Endpoint, Selected Networks. And then if I scroll down to the bottom, there's a section called Virtual Network. And there's a pull down, so I can choose my virtual network. Virtual Network 2255. And Subnet, I'm going to pull down the menu and choose my public subnet. And then at the bottom left, I'm going to click Review and Create. So validation is successful. So at the bottom, I'll click Create. And now I'm just going to pause and wait for this deployment to complete. Okay, so the deployment is complete. So in the middle of the screen, I'm going to click Go to Resource. And that takes me to my Azure Cosmos DB account. And the first thing I'm going to do is set the firewall. So on the options on the left, under Settings, the fifth down is Firewall and Virtual Network. So I'll click on that. And what I want to do is add my current IP. So part of the way down the screen, there's a section that has IP addresses. And there's an option in blue to say Add my current IP. So I'm going to click on that. And at the bottom left, I'll click Save. That allows me to interact with my Cosmos DB through Azure by using tools such as a Data Explorer. Okay, so it's said that that is successful. So on the left menu, I'm going to choose Data Explorer. And on the right-hand side, I have the Data Explorer. And at the top left of that area, there's a section called New Container. And I'm going to pull that down. And I'm going to choose New Container. And I get a blade on the right called Add Container. The first thing it asks for is a database ID. So I'm just going to call this Demo. And if I scroll down, it also asks for container ID. So I'm also going to call that demo. And then at the bottom left, I'll click OK. Oh, and there's one thing I forgot. You also have to enter a partition key. This is required. So I'm going to use the default, which is /event_ID. So this is a key that has to be in all of your records, and it's used for partitioning. So at the bottom left, I'll click OK. Okay, so that has been created. So on the left-hand side of the Data Explorer, you can see that under Data, there's now a database called Demo. And if I open that up, it contains a container called Demo. And if I open that up, there's an option for items. I'm going to click on that. And on the right-hand side, I get an item view. And at the top of the screen, there's an option for new item. I'm going to click on that. And in the code window on the right, it shows me the new item. So it creates a default item. I'm going to change this slightly. It's just a JSON object. On line 2, I'm going to change ID to event_ID as the property name. And as the value, I'm going to just give it the value 1. It's a unique identifier. And then comma, and I create a new line 3. And on line 3, I'm going to create my own field called message. And that message is going to say the following. If you can read this, you have retrieved data from Cosmos DB. Now at the top of the screen, I'm going to click Save on the main menu. So that saved that JSON object as a record in my demo container in the demo database. And that's what we're going to read from Databricks. So the next step is to go to Databricks and actually read this. So I'm going to click Home at the top left. In my recent resources on my home page, I'll click Databricks 2255. And now I'm on the overview of Databricks. So on the right-hand side, if I scroll down, I see a blue button called Launch Workspace. I'll click that. So now I'm signed into Databricks. So the first step here is to create a cluster so that we can run some code. So in the menu on the left, 6th button down, I'm going to click Clusters. And then on the Clusters table on the right-hand side above it, I'm going to click Create Cluster. Now I'm on the New Cluster window. It's asking me for a cluster name, so I'm just going to call it Demo-Cluster. Cluster mode, I'm going to set to single node just to keep it simple. And under Databricks Runtime Version, I'm going to pull this down and I'm going to choose 6.4. This is important because we're going to be using a library that relies on Scala 2.11 and does not work with 2.12. So you need to choose this runtime. At the top of the screen, I'll click Create Cluster. So this will take a few minutes, so I'm just going to pause and wait for that to complete. Okay, so our cluster is live. So the next thing we're going to do is create a notebook. So I'm going to click the Databricks button at the very top of the left menu. And on the main Azure Databricks page, under Common Tasks, I'm going to click New Notebook. And I get a Create Notebook pop-up. And I will give it a name, and I'm just going to call it Demo Notebook. Default language is Python, that's fine. And our demo cluster is the cluster. So I'll click Create. At the top left, it looks like it's still detached, so I'm just going to choose my demo cluster at the top left. I get a pop-up window, click Confirm. So now at the top left, it shows I'm connected to my demo cluster. So now I'm going to run some code to talk to Cosmos DB. Now remember, they're on the same virtual network, and there's an endpoint, so Demo Notebook should be able to talk to Cosmos DB. So the first thing we're going to do is create some configuration for a connection. So in the code window, I've placed the following. On line 1, it says connection equals, and it starts a JSON object. Line 2 says endpoint. This is the endpoint for your Cosmos DB. So let's go back to Azure for a moment, and I'll click Home at the top left of my Azure screen. And under Recent Resources, I'm going to choose my Cosmos DB 2255. And on the overview of my Cosmos account, on the right-hand side, there's a URI, and I will copy that. Then I'm going to go back to my notebook, and on line 2 of the code window, I'm going to paste that URL as the endpoint. Now on line 3, it asks for a master key. Again, that's your Cosmos DB key. So if I go back to Azure, and I'm still on my Cosmos DB account overview, on the left-hand side, I'm going to scroll down to Settings, and I'm going to click Keys. Now on the right, there are some keys, and I can copy the primary key. So I'll just copy that to clipboard. Then I'm going to go back to my notebook in Databricks, and on line 3 in the code window, I'm going to paste that key as my master key. Now on line 4, it asks database. This is a database name, and I don't have to go back for that because I remember it's simply called demo. And on line 5 is collection. That's our container that we created in the database, and we also called that demo. So on line 5, I'll fill in demo. Line 6 is fine. It's a query custom. This is the query it's going to use to get data from that collection. Collection and container are the same thing. So it's going to get that from the container. Select star from C. That's the query that's going to run, so it's going to get everything. So I'm going to hit Shift-Enter to run this. That's complete. Now that didn't do anything really. All it's done is created this connection variable that has this information. The next step is to actually get the data from Cosmos DB. So in the next code window, below the first one, I'm going to paste the following. On line 1, data equals spark.read.format com.microsoft.azure.cosmosdb.spark .options ** connection .load. So this takes that connection detail and it connects to Cosmos and it actually loads data into a data frame called data. And then line 2, data.create or replace temp view Cosmos data. This takes a data frame data and it creates a temporary view out of it that we can query using SQL statements. Now before we run this, we actually need a special library because this com.microsoft.azure.cosmosdb.spark on line 1 is referring to a specific library. So I'm going to leave this notebook for a moment, and on the left-hand menu, I'm going to go back to clusters. And under clusters, I'm going to click on my demo cluster. And on my demo cluster page, at the top, third from the left, is a libraries option. So I'm going to click libraries. And on the libraries page underneath, there's an install new button. I'm going to click that. And I get an install library pop-up. And by default, the library source is upload and the library type is jar. So I'm going to upload a jar file that is a library that allows us to use Spark to connect to Cosmos DB. So it says drop jar here. So I'm going to open a file explorer and I'm going to go to my file. It's Azure Cosmos DB Spark and it has a bunch of numbers, jar. I'm going to drag this and drop it here and let it load. And then at the bottom right, I'm going to click install. So in the libraries table, it says status installing. And it's got a little icon showing it's installing. And now we have a solid green circle, so it's installed. So now I can go back to my notebook. So on the left menu, I'm going to click Workspace, third from the top. And I see my demo-notebook. So I'm going to double click on that. So now, just for good measure, I'm going to rerun the first code. So I click on the first code window at the top and hit Shift-Enter. That sets the connection object. And then in the second code window, I'm going to click and hit Shift-Enter. And that runs a Spark job which actually gets the data frame and then creates a temporary view. So now I should be able to use a SQL statement to query the data from Cosmos DB. So here's that statement. On line 1, I say %SQL. This just says that I'm going to be using SQL. And on line 2, select Cosmos data.message from Cosmos data. If you go back to the previous code window on line 2, Cosmos data was what the name we gave to the temporary view. So we're querying that temporary view and getting the message that I put in that record. So I'm going to hit Shift-Enter on that. And on the results, you can see the message. If you can read this, you have retrieved data from Cosmos DB. So we're successful. In this video, I'm going to show you how to perform an extract, transform, load pipeline, or an ETL using Azure Databricks. An ETL pipeline is useful when the transforms that you have are static and they're known before the data is queried. So in Azure, I have some resources already set up. The ones we're going to use today are a Databricks instance. Mine is called Databricks 2255, and a storage account. Mine is called Storage 2426. So let me show you how the storage account is set up. I'll click on that. And under the overview of the storage account, I'm going to click Containers. And under Containers, I have two containers set up, Source and Target. So we're going to extract from the source, and then we're going to do our transform, and then we're going to load into the target. Now, in a real-life scenario, these would be in different databases typically, but we're just going to simplify it here as two containers. Now, if I click on Source, I have one blob called us-500.csv. I'll click on that. And on the details of that CSV on the right, I'll click the fourth tab from the left, Edit. And we have 500 records. And if I click the Preview button at the bottom, you'll see it has a lot of columns. And if I scroll to the right, there's a state column. Now, what our transform is going to be today is we're going to filter this to only the state of Illinois. And we're going to only show a subset of the columns, only the details of the company and its address. So if I back up by going to the top left and clicking Storage 2426, and then in my containers I click Target, I just want to show that my target is currently empty. So now I'm going to click Home at the top left, and under Recent Resources, I'm going to click Databricks 2255. And that takes me to my overview of my Databricks. So if I scroll down, I'm going to click on Launch Workspace. So I'm signed into Databricks, and I have a cluster already running. I'll just show it to you quickly. So if I go to the left menu, 6 button from the top, I click Clusters, and I have a cluster called Demo-Cluster. It's a very simple setup. If I click on it, it's a single node cluster, and it's running Databricks Runtime version 6.4. Now we're going to create a notebook and use it against this cluster. So I'm going to click the Databricks icon at the very top of the left menu. And then on the right-hand side under Common Tasks, I'm going to click New Notebook. And I get the Create Notebook pop-up window. So I have to give it a name, so we'll just call this Demo-Notebook. Default language is Python, and cluster is Demo Cluster. And on the bottom right, I'll click Create. So now we have our notebook on the screen, and I have a code window in gray. And so the first thing I'm going to do is do the extract. So here's the code for the extract, and let me step you through it. Line 1 is setting up authentication to talk to the storage account. It needs a key to talk to the storage account. Now, the first argument of this spark.conf.set is fs.azure.account.key.storage2426.blob.core.windows.net. Note that the name of the storage account is in here, storage 2426 between key and blob. So just fill in the name of your storage account if you have a different account. The second argument is the key for that account. Now here it's blank, so I have to go and get it. So I'll go back to Azure, and on Azure at the top left, I'll click Home. And then under Recent Resources, I'll click my storage account, Storage 2426. So now in the menu on the left, I'm going to go down to Settings, and I'm going to click Access Keys. And on the right, under Access Keys, I have a button called Show Keys. I'm going to click that. And that shows me all of the keys. And under Key 1, I'm going to click the Copy to Clipboard on the right side of the key. So that copies the key for me. Now if I go back to my demo notebook in Databricks, on line 1, I'm going to paste that key in the second argument of spark.conf.set. So that will configure the key. Line 3 is the actual read. So df stands for data frame, and it's just a variable I'm creating to store the data when it comes in as a data frame. So df equals spark.read.option, and this option sets the header to true, which just tells it that my CSV has headers for the columns. And then .option in first schema true tells it to try to determine the schema based on the contents of the fields. And then .csv, and then it points to the CSV we want to load. There's a specific format to this string. It goes WASBS : // and then the name of the container inside my storage account at the name of the storage account .blob, .core, .windows, .net. So that takes it to the container that you want to talk to, and then / and what's in the container. So in this case, the CSV is inside that source container. So that will read our data into a data frame called df. On line 5, I say display df. So that will display the contents of that data frame. So I'm going to click on the code window and then hit Shift Enter to run it. So it's complete, and if we take a look, there's a table in the results, and if I click on it, I can scroll down and there's 500 records. And if I scroll to the right and I look at the state column, we only want the rows that are in state Illinois, so that's IL. So now that we have the data in a data frame, we can do a transform on it. So we'll go to the next code window underneath that one, click on it, and here's the data we're going to run. This is our transform. Line 1, I'm creating a new data frame, which is a transform data frame. I'm calling that DFF. DFF equals the original data frame dot where, so we're doing a where clause, state equals IL. Dot select, and this is where it selects the columns we want to keep. Company name, address, city, and state. So of all the columns, those are the only ones we're interested in. And we're only going to get the records where state is equal to capital I, capital L. Line 2, I display our transformed data frame. So let me click on this code, and then I'm going to hit Shift Enter. And now it's run it. So now you see that we only have the 4 columns. And if I scroll the table in the results, they're all Illinois state. So that's the E and the T. We've extracted all of the data. We've transformed it to what we want. And now we're going to load it into the target. So let's go to the next code window, Command 3. And this is what we're going to run. It's a single line. DFF, that's our transform data frame. Dot write, so we're writing it as a CSV. Dot option header true, so that's just stating that it has column headers. Dot mode append, that means that anything that was written before will not be destroyed. It will just write a new file, and it'll keep the historical data. Dot CSV, and then here it points to where to write it to, and this is in the same format as the read. WASBS : / the name of the container, which is target, at the name of the storage, which is storage2426, .blob, .core, .windows, .net, / and I give it the CSV. This time I append -mod to the name, US-500-mod.csv. So I'll click on the code window and let me hit Shift Enter. And it says that it's completed running that. So let's go back to Azure and take a look at our target now. So in Azure, I'll click Storage2426 at the top left to go to my overview. And on my storage overview on the right, I'll click Containers. And then in the container list on the right, I'll click Target. And you see that now my target has data in it. Now there will be a CSV in the root, and that will be empty. This file, you see the size is 0 bytes. The data itself is actually in a folder called US500mod.csv. If I open that up, there are several blobs. One is a blob of when it started, and you can see the time it started, and then when it was committed. And the committed has some information that tells you where the data is. If I open it up, so I clicked on the committed file, and on the details on the right, 4th tab from the left, I'll click Edit. And you can see that there is a Json object on line 1, and it tells you the name of the file that it added. So the actual data is in a file that starts with the word part. So on the left, it's called part 0000 TID, etc., etc. So I click on that. And on the blob details on the right, I'll click Edit. And you can see that I have on line 1, company name, address, city, and state. And if you look at each row, the state is actually Illinois. So we've loaded the transformed information. In this video, I'm going to demonstrate how to perform sentiment analysis on data using Databricks and a text analytics service in Azure. Now, this is just one example of using external analysis services in Databricks. So I'm in Azure, and the resources that I'm going to need are a Databricks account. And under recent resources, you can see I have a Databricks BB, which is my Azure Databricks service. And you're also going to need a text analytics service, which is a cognitive service. And that's also under my recent resources. Mine is called Text Analytics BB. But let me quickly walk you through how you would create your own. So in the top left of my home screen, I'm going to click Create a Resource. Then on the new screen, in the search window, I'm going to type Text Analytics. And I'll choose Text Analytics from the dropdown. And on the Text Analytics screen, I'll click Create. And creating this is really simple. I'm on the Basics tab of Create Text Analytics. And under Project Details, I choose a subscription. It's already chosen my subscription because it's the only one. And I can either create a new resource group or choose one that I have. So I'm going to choose the one I have. And then under Instance Details, you choose your region and you give it a unique name, and then you choose your pricing tier. There's a free tier if you want to use that. I've already used that in my instance, so I'm not allowed to use it twice. So for this example, I'll just choose one. And then you can click Review and Create. And then when validation passes, you can click Create at the bottom left. Now I've already created one, so I'm not going to do that. So in the top left, I'm going to click Home. And another resource that we're going to need is a storage account. I also have one of those set up. So under Recent Resources on my home page, I have Blob BB. So let me open that for a minute and show you what I have set up. So in my storage account, on Overview on the right, I'll click Containers. And under Containers, I have a single container called Demo. So I'll click on that. And in Demo, I have a single blob, sentiment.csv. If I click that, and on the details for sentiment.csv on the right, I'll click the fourth tab from the left, Edit, and I get an edit window. And on line 1, I have the name of the single field, which is message, and lines 2 through 5 are my messages. So you could think of these might be text messages. And what sentiment analysis does, it's just one of many text analytics you can use. And this one analyzes a text and gives an idea whether it's a positive or negative sentiment. So you'd expect on line 2, I love to use Azure for all of my data needs. Should be a fairly positive sentiment. Line 3, today has not been the best day. That's probably a negative sentiment. Line 4, I'm looking forward to the start of the new semester. That sounds positive, so it could be a positive sentiment. And line 5, my cable provider is really making me mad. That sounds very negative, so that's a negative sentiment. So we're going to run this through the analytics and see what it says. So I'm going to click Home at the top left again. And now, under Recent Resources, I'm going to click my Databricks Instance, Databricks BB. And on the overview on the right, I'll scroll down and I'll click Launch Workspace. So I'm in the workspace. On the far left menu, 6 button from the top, I'm going to click Clusters. And on the Clusters page, I have one cluster running called Test Cluster. I'm going to click on it and just show you what I have set up so you can set up something similar. So on the Test Cluster page, cluster mode is single node because it's very simple. Databricks runtime version, I just chose the default, and that's 8.0. And I left everything else default. So it's a very simple single node cluster. Now I'm going to create a new notebook. So on the left-hand menu, I'm going to click the very top button, and that takes me back to the home page. And on the left, under Common Tasks, I'm going to click New Notebook. Now I get the Create Notebook pop-up, and I'll give this a name. I'll just call it Demo-Notebook. Default language is going to be Scala, and the cluster is my test cluster. So I'll click Create at the bottom right. So here's my demo notebook. At the top left, I verify that it says test cluster, and that is running because it's got a green circle beside it. And I have a code window. So in the first code window, I'm going to place the code to get started, and I'll step you through it. So this code actually calls the API of the text analytics. I'm going to skip over the imports because these are just the imports that we need for the various calls we make. On lines 7 and 8, I create a couple of classes that help me to consume the response that I get back from the text analytics API. So on line 7, I have a class sentiment, and that consists of a documents property, which is an array of sentiment documents. It also has an errors array, which we're going to not be using in this demo. On line 8 is a class called sentiment documents, which sentiment uses. It's the array type, and it has an ID, which is a string, and a score, which is a double. That score will be our sentiment score. So carrying on lines 10 and 11, I set up a couple of variables. Line 10 is called text analytics account. So that is the name of our text analytics instance. So if I go back to Azure and I click home in the top left, you'll see under recent resources my text analytics instance is called text analytics BB. So going back to Databricks, that's what I'm going to fill in on line 10. Line 11 is text analytics key. That's the secret key or the access key that I need to access my text analytics. So I'm going to go back to Azure. Under recent resources on my homepage, I'm going to click text analytics BB, my text analytics instance. On the left menu, under resource management, I'm going to click the second option, keys and endpoint. Now on the right-hand side, I'm going to click show keys. So now I can see my keys, and I'm going to copy key 1. So on the right-hand side, I'm going to click the copy to clipboard button. Now I'm going to go back to Databricks, and on line 11, I'm going to add that key as text analytics key. So those are the credentials, essentially, for talking to the text analytics API. On line 13, I create a user-defined function. Now, a user-defined function can be used in a data frame to specify the values of a column, and you'll see how we do that later on. My user-defined function is called asSentiment, and it accepts as an argument a string called content, and that will be the string in a cell of a column. Starting on line 15, we set up a post request because we're talking to an API, so we're going to do a post to that API. On line 16, I'm setting up a Json object, which is going to be the body of my post request. In curly brackets, and all of the double quotes inside the string have a backward slash, but they're just double quotes. So curly bracket, double quote documents. So it's a property called documents. And that property is an array of other JSON objects. And I just have one object in the array. It has an ID, a text, and language. The language is hard-coded to be EN, which stands for English, to tell it what language it's looking at. The ID is just a unique ID, and the text is a text you want it to analyze. I set ID and text both to content in my format. So it's going to replace the %s's in my string with the value content. On line 17, I create an entity. It's a string entity with my JSON object, so it turns it from a string to an entity, and it URL encodes it. Line 18, I set up my post. I create a new HTTP post object, and I give it the URL to post to. And my URL looks like this, https://, and then the name of my text analytics account. So this is where I'm going to do my formatting %s. And on the far right of this line, you see I'm formatting with text analytics account. So that %s will be replaced by my account name from line 10. .cognitiveservices.azure.com /text/analytics/v2.1/sentiment. That is the endpoint that we need to call to get this sentiment to work. On line 19, I set that entity on the post to be the body of the post. On line 20, I set a header, and it has to be called OCP-APIM-subscription-key, and that's my text analytics key from line 11. And then on line 21, I set the content type to be application JSON. So that sets up my post call. Starting on line 23, I send the post request. Line 24, I use the HTTP client builder object, and I call create.create.build, and that creates an HTTP client I call client. On line 25, I call a client.execute, and I send my post object, which is from line 18, which is an HTTP post, and it sends me back the response. Then starting on line 27, I turn that response into a sentiment object. On line 28, I do a scala.io.source.fromInputStream response.getEntity.getContent. So that essentially gets the content, which is an input stream, and then it goes .getLines.mkString. That turns that content into a string. So at the end of this big line, what I get is a response string, which I call response string. That will be in JSON. Line 29, I create a new Json object, which will help me translate from JSON to an object. On line 30, I do that translation, json.fromJSON, and I give that call the response string, which is the JSON in string form, and I say class of sentiment. If I scroll back up to line 7, that's the class I defined, which represents what you get back from this call. It's an array of sentiment documents. Finally, on line 32, I get the value that I want to return for this cell. The object that I've created, .documents bracket 0, so get the first document, because we're only asking for one, so it'll return 1. .score, that's the score of the sentiment document. So that will give us our actual sentiment value. So what this UDF, or user-defined function, does is every time it's called with a string, which is represented by a cell in a column, it will return what the column value should be as the score on line 32. So I'm going to hit Shift-Enter and run this, and it tells me that it's complete. So now we move on to the next part, which is actually getting our data from our blob and then running the sentiment on it. So I'm going to place this in the second command window. And lines 1 through 4, we have to fill in some blanks here. This is the configuration. Line 1 is your blob account. So if I go back to Azure for a moment and I click Home at the top left, and in my recent resources, my blob account is called Blob BB. So going back to Databricks, I'm going to fill that in on line 1. Line 2 says blob container. If you recall, our container name inside our account was called demo. So on line 2, I'll fill in demo. Line 3 is our blob file. If you recall, you could look it up in the blob storage, but if you recall, it was called sentiment.csv. Line 4, we need the blob key. That's the access key to access the account. So let's go back to Azure, and I'll click on Blob BB under Recent Resources. And on the left, under Settings, I'll click Access Keys. And on the right, I'm going to click Show Keys. Okay, so now we can see our keys. And under Key 1, I'm going to click the Copy to Clipboard on the right-hand side. And then I'm going to go back to Databricks. And on line 4, I'm going to paste that key as Blob Key. Now, to step through the code, on line 6, what we're doing is we're setting up the access key to access the blob account. So we go spark.sparkcontext.hadoopconfiguration.set, and the configuration name is fs.azure.account.key dot, and then the name of the blob account, which you see we're doing in the dot format blob account, .blob.core.windows.net. And the value for that configuration is the blob key. So that gives it the blob key, or the access key, to access the blob account. On line 8, we're doing all the work. So I get a data frame by going spark.read.option header true. What that tells it is just that in our CSV, our headers are going to be our column headers. .csv, and then for the CSV argument, I give it the URL of the blob, which is a standard format for blobs, WASBS:// the name of the blob container, @ the name of the blob account, .blob.core.windows.net, / and the name of the blob file. So those 3 pieces of information are in my format here. So the %s is replaced by the blob container, blob account, and blob file. And then I add a column using .withColumn, and the column name is sentiment, and the value, for the value, I call my UDF, which is as sentiment, as you recall. And for the argument, I give it the column message. So it's single quote message. That's how you specify the column on the current data frame. So every value in that column, it will call this as sentiment and return a value. And then line 10, I display that data frame. So let's run that. I'll hit Shift Enter. And here's our results. So we get a table. We have the messages on the left, and then the other column is sentiment, which has been created. So let's see what sentiments it gives. So for I love to use Azure for all my data needs, it gives a 0.964 with a bunch of other numbers. So we'll just go to the first few digits. This is a value from 0 to 1, 0 being the most negative sentiment, 1 being the most positive. So it thinks it's very positive, 0.96 out of 1. Now let's look at the next one. Today has not been the best day. This only gets a 0.21 out of 1, because it's not a very positive sentiment. It's more on the negative side. Line 3, I'm looking forward to the start of the new semester. This gets an even higher sentiment than the first line. It gets a 0.97. And finally, line 4, my cable provider is really making me mad. Only gets a 0.01, so that's very negative. So what you can obviously use this for is if you are collecting, say, messages for a business, you can get the sentiment of those messages and you can quickly find the positive messages versus the negative messages. So perhaps as a business, you could respond appropriately to the negative messages that you're getting. Now, the last note I want to make is the code that I've showed you is not necessarily designed for performance. Really, what I've designed this code for is brevity, so that it's easy to understand and it's short. In a production environment, the text analytics API can actually accept several messages at once. And the way we're doing it with the UDF, we're only calling it with one message at a time. So that's maybe not the most efficient, and it can be done in a more efficient manner. In this video, I'm going to demonstrate some options that you have for debugging your runs in an Azure Hdinsight Spark cluster. So I'm on my Azure homepage, and under Recent Resources, I have an Hdinsight cluster already set up called Hdinsight 2255. Let me step you through creating your own Hdinsight cluster. So at the top left of my homepage, I'll click Create a Resource. On the New page, in the search box, I'll type Hdinsight and choose Azure Hdinsight. And then on the Azure Hdinsight page, I'll click Create. And now I'm on the Create Hdinsight Cluster page. And I'm on the Basics tab on the left. So under the Basics tab, under Project Details, I need to choose a subscription, and it's already chosen mine. And I need to choose a resource group. So you would choose a resource group or create a new one. Under Cluster Details, give it a unique cluster name, and you can choose a region. And under Cluster Type, to the right of Cluster Type, click Select Cluster Type, and you get a blade on the right-hand side called Select Cluster Type. Click the Select button to the right of Spark. Then under Cluster Credentials, you need to set up your admin login. So you'd choose a cluster login username, or you could just use admin. You'd enter a cluster login password and then confirm it. After doing that, you scroll to the top and click the fourth tab from the left called Configuration plus Pricing. On this tab, you need to set up your node configuration. So under node configuration, there's a table that has the term node type at the top left, and it has 3 node types: head node, zookeeper node, and worker node. Now you'd configure this in whichever way you would like in order to run that. For this demonstration, I chose the smallest node sizes with the fewest cores. And under worker node, you can change the number of worker nodes, and I changed it to 1. Then you would hit Review and Create, and you would be able to create your cluster. Now I'm going to click Home at the top left and go back to my home page, and then I'm going to click under Recent Resources on my Hdinsight cluster called Hdinsight 2255. Now I'm on my overview page of my Hdinsight cluster, And on the right-hand side, if I scroll down, I see a row of buttons. They start with Ambari Home and they end with Yarn. The third from the left is Jupyter Notebook. So I'm going to click on that now. And that takes me to Jupyter Notebooks. And at the top right, I'm going to click New. And under Notebooks, I'm going to choose PySpark. This creates a new notebook for me. So now I have a notebook on the screen. I have a code window. And in the code window, I'm going to type something very trivial. I'm just going to type print, round bracket, and then in double quotes, hello world. This is just a trivial notebook to test with. So on the main menu, there's a Run Cell button, and I'm going to click it. Okay, so it is run, and we see the output, which is hello world. Now I'm going to go back to Azure, and on my overview of my Hdinsight cluster, I'm going to show you how you can get details about that Jupyter Notebook that just ran for debugging purposes. So on the far right of the row of buttons, I'm going to click Yarn. And this opens up the Hadoop All Applications screen, which gives you information about all the applications that have run. And the one that I just ran should be the very top one, and I see from the start time that it is. And if I scroll to the right, you see it's got a lot of information about the allocated memory, CPU cores, etc. that was run for this. On the far left, I have an application link under ID. So I can click on the ID of the application. Note that the Jupyter Notebook always runs as Remote Spark Magics under Name. So anyway, I'm going to click the link on the left, and this takes me to a specific application page for the Jupyter Notebook I just ran. And it has a bunch of information. There's a section called Application Overview. Below that is Application Metrics, and it tells me some information about attempts and containers and resource allocation. And at the very bottom, there's a table with my application attempt in it. And on the right-hand side, there's a link that says Logs. If I click on that, I get a log screen, and there are a series of links that take me to different logs. So for instance, the second from the bottom is standard error. So I can click that, and I can see details about the Spark instance running. So you can get information here from these logs for debugging purposes. Now, if I hit the back button on my web browser, and then I hit it again, I'm back in the application page for my application. So if I scroll to the top, and in the section called Application Overview, there is about 2/3 of the way down to that section a tracking URL. And it's got a link beside it that says Application Master. So I'm going to click on the Application Master link. This takes me to the Spark UI, which has a lot of useful information. First off, at the top, there are several tabs. We're on the leftmost tab called Jobs. And this is my Spark job information. It tells me the total uptime of the information is 3.7 minutes. And if I click on Event Timeline, a link on the page, it shows me a useful timeline of my job running. So it tells me when the executor driver started, and it tells me when the executor was added, and presumably it's still running because the job actually runs for some time after it gives the results. You can also get information about stages, so jobs can have several stages in them. This one will probably only have one stage. But in the options at the top, the main menu, second from the left, I'll click Stages. And actually there are no stages to this because it's just a print hello world. But there might be normally several stages that you can see details about. On the far right button on the main menu is Executors. If I click on that, I get all sorts of resource information about the executors that ran my job. So there's lots of good information here that you can use for debugging. Now if I go back to Azure, back to my overview of my Hdinsight cluster, another useful link is Spark History Server, which is the second button from the right in the row of buttons. If I click on that, you get a list of the applications that have run with links to them. And if I click on the links, I get more information about the jobs, just as we've seen before. So in conclusion, an Azure Hdinsight Spark cluster offers many ways that you can debug your Spark jobs via the Yarn and Spark History server links on the overview of the cluster instance in Azure. So in this course, we've examined Azure Databricks processing types and features. We did this by exploring available processing types when using Azure Databricks, creating Azure Databricks using an Apache Spark cluster, running jobs in the Azure Databricks Workspace, querying data in SQL Server and handling failed batch loads, implementing a Cosmos DB service endpoint, using Azure Databricks to extract, transform, and load data, and performing sentiment analysis and debugging Spark jobs. In our next course, we'll move on to Azure Stream Analytics.